talk about section 4.1 and 4.2. It's going to focus primarily on section 4.2, which deals with isosceles and equilateral triangles. In fact, the only thing that we're going to talk about section 4.1, which is about congruence, is the fact that in section 4.1, we learned that congruent figures result from rigid transformations. In fact, that's it. That's the big thing that we need from section 4.1. The fact that if we want to find two figures that are congruent, we either need to show that all angles have a corresponding congruent angle, and all sides have a corresponding congruent side. Or we need to show that there exists a rigid transformation from one figure to another. Now for section 4.2. Because quite literally we're being quick here with 4.1. In 4.2 we have isosceles and equilateral / equiangular triangles. So, an isosceles triangle, shown here, has a couple of things about it. First off, it has two sides that are congruent to each other. Now, those two sides actually have two angles that end up being congruent. And we have a couple of parts. These two angles down here are referred to as base angles, and this side length is referred to as the base. So, let's get some true and false stuff out here. The perpendicular bisector of one side of a triangle bisects the angle opposite that side. This is not always true. This is true with equilateral triangles, and it's also true if we are talking about the perpendicular bisector from the that bisects the base of that triangle. If a line bisects the vertex angle of an isosceles triangle, then it is perpendicular. Then it is a perpendicular bisector of the base. This is true because we have base angles and we have our vertex angle. So we can kind of consider this to be true. If the line is a perpendicular bisector of the base of an isosceles triangle, then it bisects the vertex angle. True. Now, equilateral or equiangular triangles. If a triangle has three congruent angles, then it has three congruent sides. This is true. If we know that all the angles are congruent to each other, we know that all the sides are congruent to each other and vice versa. Specifically, if all the angles are congruent to each other, that means that we have an angle measure of 60 degrees for every single one. So, three congruent sides does mean that it has three congruent angles. This is true. If a triangle has three sides, then they are all congruent to the to its three angles. False. All triangles have three sides, which is why this statement is clearly false. Now, let's find the value of x. My lettering is a little off here. I'm not quite sure what happened, but I do apologize. Okay, let's look at this first triangle. I'm told that this side and this side are congruent to each other. And because I know that these two sides are congruent to each other, I know that these two angles have to be congruent. So, x plus 7 must equal 57, or x equals 50 degrees. For A, the two angles here are congruent to each other. Since those two angles are congruent to each other, these two sides must be congruent to each other. So x plus 22 must equal 33, and this is going to be x equals 11. For B, the two base angles, I'm told they are congruent, which means these two sides are congruent. So 4x minus 9 must equal 2x plus 27, and 4x minus 9 equaling 2x plus 27 means that we can solve for x. We would subtract 2x from both sides, giving us 2x, and we would add 9 to both sides, giving us 36. So 2x is 36, meaning that x is 18. And then over here, we have, again, these two sides we're told are congruent. And since we were told the two sides here are congruent, their angles must be congruent. So we have 2x minus 2 equals x plus 2, which means that x must equal 4 degrees. Or x must equal 4, and then we can plug that in to figure out our total angle measure, which would be 6. So these are small angles, to say the least, but as long as the angle is greater than 0 and less than 180, it could be an angle of a triangle. Okay, that does it for this video, and I will see you in the